Hi, today we're working on solving equations with radicals, and we're solving for a variable. Here we go. Please read the power rule for solving an equation with radicals. Read through all the examples. Our whole goal is to get rid of the square root. Depending on what the radical is going to be, it's either going to be a square root, a cube root, a fourth root, whatever it happens to be. In order to get rid of a square, you square root it. So in order to get rid of a square root, you square both sides. So on this problem right here, my goal is to get rid of the square root. So by getting rid of the square root, I am going to square both sides. So I'm going to square this side, and I'm going to square this side. By squaring both sides, it gets rid of the radical. So here, whatever's under the radical comes out. Equals, on this side, 4 squared is 16. Now, my goal is to get 5x by itself because I want to solve for x. So I'm going to minus 1 from both sides. And I'm left with 5x equals 15. Again, I need to find out what x is, so I got to get rid of the 5. So I'm going to divide both sides by 5, and I'm going to have x equals 3. Now, if you want to check your answers, you can. So if you check your answers, you're going to go, we're not checking answers after this. I just want to show you how you could check your answers if you wanted to. So we know that our x value is 3. So wherever there's an x, we're going to put in a 3. So now 5 times 3 is 15. 15 plus 1 is 16. The square root of 16 is 4, and yes, it equals 4. So we know it works. You do not have to check your answers. I just wanted to show you if you wanted to. Now, my goal is, and I'm going to go through these steps as I do each problem. My goal is to get the square root completely by itself. Now, as long as there's not a number in front of here and a number behind it. However, in this problem, there is a number behind it. My goal is to isolate the square root. So I'm going to minus 2 from both sides. And I get the square root of 5x plus 3 equals negative 2. Now, I need to get rid of the square root. So that means I have to square both sides. Now, when I square root something that is being squared, whatever's under the radical is going to come out, because this square root and this square, they cancel each other out. So I'm left with 5x plus 3 equals, now a negative 2, whoops, if I square one side, I got to square the other side. So a negative 2 squared is 4. Negative 2 times negative 2 is 4. Now my goal is to get 5x by itself. So I'm going to minus 3 from both sides. And I get 5x equals 1. Now once again, I need to get x by itself. So I'm going to divide both sides by 5. And x is equal to 1/5. And there you go. That's it for that one. You can always check your answers, but we don't need to. Now, next one. Again, this one is different. As long as my radical is alone, I don't care what's on the other side. I just need to make sure that my radical is completely isolated, and it is. There is nothing in front of it, and there's nothing right behind it. So what I'm going to do on this is I'm going to square both sides. Now, if you notice, on the other side, it's x plus 1. So I got to grab that whole thing and I got to square it. So on this side of the equation, I'm left with 5 minus x equals. Now over here, I have x plus 1 times x plus 1 because I have 2 of them. I can use that shortcut trick from way back in when we talked about perfect square trinomials. But anyways, I'll show you that one in just a second. I'm just going to multiply these two together because it tells me I have 2 of them. X times x is x squared. Whoops, I forgot to get this started. And x times 1 is x. 1 times x is x. And 1 times 1 is 1. So when I add the like terms, I get 2x and then 1. So this over here is going to be x squared plus 2x plus 1. Now, Because I happen to have a square, I know I'm going to end up having a quadratic equation, which means I'm going to have to factor it. So I need to move everything over to the other side, which I'm going to minus 5, and I'm going to add x. I'm going to add x here, and I'm going to minus 5 here. So I get 0 equals x squared plus 3x minus 4. So now, because of this, this tells me that I can actually solve for x by using factoring that we factored before. We can factor this because it's got a 1 here. So I got 0 equals something times something. The only way to get x squared is x times x. Now I have this negative 4 over here. I need to find two numbers when multiplied together give you negative 4, but when added together give you 3. I'm going to do 4 times negative 1. That gives me negative 4. And I know that 4 plus negative 1 gives me 3, and that's my middle term. So this is going to be a positive 4, and this is going to be a negative 1. You need to set these, you're going to use the zero factor property, and you're going to set these equal to 0. So x plus 4 equals 0, or x minus 1 equals 0. Your goal is to get x by itself. So I'm going to minus 4 from both sides. The first answer is going to be negative 4. Or, over here, I'm going to add 1 to both sides, and I get x equals 1. Now, one of the things about this is sometimes you need to show some work and double check your answers. When you have radicals, it's probably a good idea to check your answers to make sure that it really, really works, okay? I can tell that this one works, so we're fine. All right, the next one. The next one, once again, whatever's under the radical, you must isolate it. Well, this one here is already isolated. So the square root of 1 minus 2x minus x squared is completely isolated. So in order to get rid of the square root, you're going to square it. Whatever you do to one side, you must do to the other side. So whatever's under the radical comes out. So it's going to be 1 minus 2x minus x squared equals. Now remember, we just did this one over here. This is, and I'm going to use that, the square of a binomial square. You square the first term, which is x squared. You multiply x times 1, which is 1x. You double it. That gives you 2x. And then you square the last term, which is 1 times 1. And we just did this, so I just did a little shortcut real fast. Now my goal is to get everything on one side of the equation. So what I'm going to do is I'm going to add x squared. I'm going to add x squared. I'm going to add 2x. I'm going to add 2x. I'm going to subtract 1. I'm going to subtract 1. So you end up with 0 equals 2x squared plus 4x, and the 1's cancel away. Now I'm going to factor this. I notice that they both share a 2 and they both share an x. So I'm going to factor out a 2x. It's going to leave me x plus 2. So what you're going to do is you're going to take the first part and you're going to set it equal to 0. Or you're going to take the second part, which is set it equal to 0. I'm going to divide this by 2. My first answer is 0, or I'm going to minus 2 from both sides, and I get x equals negative 2. So those are my two answers. All righty. Let me see how many minutes I have left. I think I can finish it. Let's keep going. All right. So the next one, you guys, is a little different. It can be a little bit, it'll keep us a little bit busier. So what I'm going to do is I have a square root of 2x plus 3 plus the square root of x plus 1 equals 1. So what I need to do is I need to get a radical on one side and, well, it doesn't really matter. I can square both sides. So I would like, I need to just, whoops, I don't know what I just did, but I did something weird. So I'm just going to square both sides. So I'm going to take this whole thing and I'm going to square it. And then I'm going to take this here and I'm going to square it. So what I'm going to end up doing is a bunch of math. So I have the square root of 2x plus 3 plus the square root of x plus 1. And I'm going to multiply it by itself because I'm squaring it. 2x plus 3 plus the square root of x plus 1. This is not a pretty problem. This side's easy. It's just 1. So I'm going to multiply these two together. Now, because I multiplied them two together, basically I'm squaring it. So whatever's under it comes out. That's no big deal. Then I'm going to take this and I'm going to multiply it here. So here's the weird part. I'm going to get plus the square root. Now this is going to be ugly because it's going to be 2x plus 3 times x plus 1. And this is all going under that radical. So this times this is 2x squared. This times this is a positive 2x. This times this is a positive 3x. And this times this is a positive 3. So you clean it up a little. That gives you 2x. That gives you 5x. And that gives you 3. That is not a pretty problem, but that's going to go under here. 2x squared plus 5x plus 3. Now, I'm going to multiply these two together. If you notice, I'm going to have the same thing. I don't even have to waste my time because I just did it. That's going to give me 2x squared plus 5x plus 3. Then I'm going to multiply these two together. And when I do that, it's basically squaring them. So that's just going to give me a positive x plus 1. Now combine like terms before you do anything else. These two here are like terms. So that's going to be 2 square roots of 2x squared plus 5x plus 3. I have 2 of them. And then I have a 2x plus a 1x gives me 3x. And then I have a 3 plus a 1 gives me 4 equals 1. So, oh my goodness. What we're going to do now, though, is we're going to move everything to the other side. So I'm going to minus 3x from here. I'm going to minus 4 from here. So I'm going to minus 4 from here, and I'm minus 3x from here. So that's going to give me 2 square roots of 2x squared plus 5x plus 3 equals, and over here I'm going to get a negative 3x minus 3. That is a lot of work, but we're doing good. All right. Now, this here, I noticed something, and I have a funny feeling. Let me just double check it. I don't think it's going to help me with anything. It's not. Totally not going to help me with anything. But I need to get rid of the 2. So what I'm going to do is I need to get that square root by itself. So I'm going to divide this by 2, and I'm going to divide all of this by 2. So what happens is I'm left with the square root of 2x squared plus 5x plus 3. This is a horrible problem. Equals negative 3x minus 3 all over 2. Now, I need to go ahead and get rid of the radical. So I'm going to square both sides, and I'm going to square both sides. So this gives me, let me go over here and put it all the way over here. That gives me 2x squared plus 5x plus 3. And the reason why is because it makes the radical go away. Now on the other side, though, I'm going to get 4 in the denominator, I know for sure, because 2 squared is 4. And this is going to give me a negative 3x minus 3. I'm going to square it. And I'm going to get 9x squared plus 9x. So doop, 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 doop. That's going to give me a positive 9x. and that's going to give me a positive 9. So I get 9x squared plus 18x plus 9. So on this side of the equation, I get 9x squared plus 18x plus 9. So we are almost finished. Your goal is to move everything to one side of the equation. And these don't have fractions. However, we're going to make it work. I was trying to think if there was an easier way to do this, but I don't think there was. And I don't like fractions. So I'm going to break this all up just so that you can see it a little clearer. 2x squared plus 5x plus 3 equals 9/4 x squared plus 18/4 x plus 9/4. All right. Now the 18/4, I can actually simplify that a little bit. 2 goes into this 9 times, 2 goes into that twice. I don't know why I need to do that, but I'm going to do that anyways. So I'm going to minus 2x squared here, minus 2x squared here, minus 5x here, minus 5x here, and minus 3 here, minus 3 here. So you're left with 0 equals, I need to make a 4 here. There cannot be squaring twice, but I guess it is. So this is going to be 4. Whoops, let me change colors. This is going to end up being 4, and that's going to be 8, right? This is going to have a 2. So 2 and 2, that's going to give you a 10. And this needs to have a 4, and that's going to be a 12. So you will end up with 1/4 x squared. This one will give you 9/2, and that's going to be a negative 10/2. So it's going to be a negative 1/2. This one here is going to give you a negative 3/4. Okay. Now I don't like fractions personally. So what I'm going to do is I'm going to get rid of the fraction. And that means I'm going to multiply the whole thing by 4. 4 times this is 0. 4 times this is x squared. 4 times this, 2, is negative 2. I think I left the x off of that one. X. 2 goes in that. Yeah. And then the other one is going to be a negative 3. So I can factor this. And the way I would factor it is parenthesis times a parenthesis. And it looks like I have room on the next page, so I'm going to go ahead and do that. X0 equals x squared minus 2x minus 3. I believe that's what it was. Yep. So I'm going to factor this. And my target number is, first of all, the only way to get x squared is x times x. I have negative 3. When you multiply two numbers together, you've got to get negative 3, but when you add them together, you've got to get negative 2. So I know that negative 3 times 1 is negative 3. I know that negative 3 plus 1 is negative 2. So this is going to be a negative 3. This is going to be a positive 1. You just set them both equal to 0. This was a really horrible problem. And you get x equals 3 or x equals negative 1. You do probably want to check that and put that back in there, because if you end up with a negative number under the radical, it's probably not the right answer. All right. Gosh, that was a terrible problem. I would never give you guys a problem that looked like that. But anyways, how many more problems do I have? I think I can make it. I better hurry. Now this one's nice. This is the cube root. What you're going to do is you're going to cube both sides. Cube both sides. Whatever's under there, you're going to take them out. You're going to get the x's on one side, numbers on the other. So I'm going to move the 2x over. I'm going to add the 2 over here. So 7, 8, 9, and this is x. And one last one. This one here, they want you to solve for r. So you're going to square both sides, and you get z squared equals r over t. I want to get r by itself, so I'm going to multiply both sides by t, and I'm going to get t z squared equals r. And that's it. Let me stop this real quick before it runs over.